Okay. So, before, shabab. So everyone, before I start today, once we finish this one, once we finish the first page of this, I will give you this. So not exactly this one. This is the one we covered over the last couple of days, right? We finished it completely. Okay. So I will give you something that looks exactly the same, just different. What? Just instead of nitrogen, I'm going to choose something else. Instead of beryllium, I'm going to choose something else. Same idea. You have to sketch the diagrams and then tell me if it's a positive or negative. And then you have the exact same table, just 6 different ones. You have to tell me the name. So what was the name for this one? You remember? Sodium, not fluorine, fluoride. So I'm gonna give you something like maybe calcium chloride. You have to write calcium chloride. Okay. Each one of these is what? For marks. I'm gonna give it to you today for marks. So I'm gonna give it to you today, but I'm gonna give you some time to work on it today. And I don't care if you do it all together, like you discuss the answers. It's not due today. It's due tomorrow. So you bring it with you tomorrow, all fully done, and you. Yeah. So I'm going to give you something that's very similar. So the same ideas from yesterday, today as well. Okay? And then here, what do you do here? You have the what? You have the name. You have to give me the formula or the chemical symbol. So sodium phosphide, that was Na3P. Now, I don't care if you show me how the crisscross happened. If you just write the final answer and it's correct, you get full mark. By the way, each one of these is worth 1 mark. So this question is worth 6. 1, 2, 3, 4, 5, 6. This one is also worth 6. 1, 2, 3, 4, 5, 6. But by the way, if you got the name wrong here, or if you get the symbol wrong here, that doesn't mean you get a 0. Basically, each one of these is worth how many marks? No. 1. But each part of the answer is worth half. So if you get 1 element right and 1 element wrong, you still get what? Half the mark. Okay? So for example, if you say this one, if you call this one, for example, magnesium fluoride, at least you got the fluoride right. So I give you half a mark for that. Okay? For these ones, this question is worth 5 marks. Sorry, 8. 5 for these two, 2 for these two. So 1 here, 1 here. And 1 for this one, half here, half here. Because it's a very simple thing. You just tell me anion or cation. Okay? So here's actually your, I'm going to give you this. This is it. So I'm going to give you phosphorus and lithium. And these are the new 6 ones. And these are the new 6 ones. This is worth 6 marks. Each one of them is worth 1. But each one, I could take half a mark depending on how you properly did it. Of course. That's why I want you to take it home. That's why it's not due today. I told you, every single thing with me, I want you to use your notes. Same thing here. Each one is worth 1 mark. But if you get half of it right, you get half mark here, half mark here, half mark here. This one is worth how many? 8. 5 for these two. So 2.5, 2.5. 2 for these two, so 1 and 1. And 1 for these two, so half and half. 1 plus 2 plus 5 is 8 marks. It's a very small thing, but you could actually use it to what? To catch up and to also get a lot of marks for this course. Make sense? So I'm going to give it to you today, maybe in half an hour. I'm not going to finish the full handout today. I'm going to give this to you in half an hour. You get to start because I don't want you to be stuck with it tomorrow and have to do it all in one day. So you start today. If you finish most of it today, great. Put it in your bag, take it home, finish it at home, or you can finish it tomorrow, maybe at lunch or something like that. Okay? All right. Okay. So let's. Okay. So what did we do over the last 2 days? What kind of compounds? If you look at your notes, get your notes from yesterday, or 2 days ago, or 3 days ago. Yes. You what, sir? Yeah, of course. Oh, what did you lost? Oh, you lost the whole thing. Okay, no problem. I have. It's okay, man. People lose things. That's fine. Like this. Where is it? Yes, this one. No, that's the first lesson. I don't have. Okay, yes. What's the title, everyone? What's written on top of the page here? Ionic. Yes. What did we say? All of these elements that we did, everyone. If I give you the periodic table, if I give you the periodic table right here, when we combined elements for the last week or so, where did the elements come from? Again, you have the periodic table. Everyone, listen up. The periodic table is divided technically into how many big regions? How many? 3. The ones on the what? Left. No. Your left. The ones on the what? Right. And the ones in the what? In the middle. When we did the ionic combinations for the last few days, where did we choose them from? Where did we choose the first element from? And where did we choose the second element from? So, okay, so that means what? Our first element was either from the what? From the, left side, or from the what? From the big what? From the big middle box. Where was our second thing from? Right. You think of me, you. So the first thing came from where? The left side or the middle, and the second part definitely came from the what side? So give me examples of things from the left side. Come on. Magnesium. Ah, left side. Left side. Left side. By the way, all of them in ene are where? Right side. So give me some stuff from the left side. You said magnesium. Sure, but it's there, but it's so special we don't use it because it's not a metal. Hydrogen is a gas. Come on. Huh? Potassium. Come on. Calcium. So those ones ending in IUM are where? Give me a bunch of the ones in the middle. Fe. What is Fe? No. What is Fe? Fe is the symbol. What's the name for the element? No, fluorine is capital F, and it's not in the middle. Come on. What's Fe? Look at your nose. Starts with I. Something iron. Okay. Give me something else in the middle. Come on. All the ones with brackets. All the ones that you need to. Left, right side. Huh? P what? It's P something, but it's not O. AU, gold. PU, not PU, no. CU, which is what? Copper. What did you say? Silver, which is AG. Okay. Now give me stuff from the right side. Oxygen. Okay, hold on. Helium, neon, argon, xenon. They are the very last group. What did we say about the very last column, the very last group? They are called what kind of gases? Noble, which means what? Are you ever able to make them react? That's why we've never seen them at all last week. Okay, go one family before. iPhone? The box right there. White cord. C what? Not CI. C, not CE. Cl, chlorine, bromine, fluorine, and so on. Okay? So we had combined something from which side? Left or the middle, and something from the what? Today we do something that we're connecting, and it's called what? Who can read this word? Again, break it down. Hold on. This part and this part. Yeah, you can just bring it back. Okay. What's the second word? Valent. Like the word valence. No. Like the word valence. Valence. You did valence, right? In the quiz. Yes, what's up? Go ahead. Covalent. Let's say it together. Let's say it. Say it with me. Covalent. Covalent. Yeah, you can go. I have no idea what it is. Okay. Yes. Sure, go ahead. Okay? So, okay. How do we do covalent compounds and not ionic? Ionic, they had to combine something from where? Left and right. What if you have to combine two things from the what? Can you combine two things? You can. Yes. In chemistry, you can either combine something from the left or the middle with something with the what? On the right. Or you can combine actually two things from the what? Right. They found that you can, I think, never combine things purely from the what? Left or the, but you can combine two things from the what? From the right side. From the what? From the right side. I'll give you, okay, the easiest proof. What do you breathe in? Helium. What do you breathe in usually? Oxygen. What do you breathe out? Carbon what? Carbon dioxide. Where is carbon? Right side. Where is oxygen? There you go. Carbon dioxide is not made of a left and right or a middle and right. It's made of two things. Where? On the what? On the right. So you can actually make things with how many things? Two things on the what? On the right. You can. But you can never make things with two things only from the what? From the left or from the what? From the middle. You can make things purely from the right. You can. It's actually very well known. Okay. So here's the thing. Do you remember when we played the coins? What happened when we always played the coins? Someone had to what and someone had to what? Someone had to fully lose and someone had to what? Like someone had to completely let go of what? One electron or two or three. And someone had to what? Take or gain that one or two, right? You had to fully, I had to completely give you something and walk away. I can't have it anymore. But you what? You can what? You can completely take it. I have nothing to do with it anymore. Here's the thing about what? Two things from the right. Because they're both what? On the what? Come on. They're both what? On the what? On the right, there is no fully lose and fully what? Fully gain. There is what we call sharing. That's the trick that you have to remember now. When you do ionic, one person, Hamad, I love that how you're doing it in front of me. One person completely loses and one person completely what? Gains. That's in the old lesson. Today, no one completely loses and no one completely what? Gains. We do what? We share. So actually what really happens is, yes. Sorry. These my, sorry, where are my coins? Okay. I don't have coins, but I have gum. Okay. So basically what? Sorry. He has some electrons and I have some electrons. I cannot fully gain. He cannot fully gain. I cannot fully lose. He cannot fully lose. So what do we end up doing? Look, seriously, this is what happens. Just, yeah, take these. That's the thing. He can't take them. No. And I can't take them. We what? Share. That's exactly how it happens. Okay? Mind you, but here's the thing. Sometimes one of us can what? Can pull what? Like it can be closer to you. But we're still what? Sharing. We're still sharing. This is what covalent means. Co means what? Co means let's do this together. Co. Have you ever heard the word collaborate? Yeah. What does collaborate mean? Yeah, when the teacher says, okay, guys, get in groups and collaborate. What does that mean? Come on. You can use Google Translate. Yeah. So work by yourself or together? Like help each other. Exactly. Help each other. Share. Some for you, some for me. Does it have to be 50-50? He could be stronger to pull closer to him. So he could have slightly more towards him than I do. Okay? All right. So why does this happen? I just told you why. Because both of them are on which side? The right side. So both of them like to what? Like to gain. Both of them like to gain. So that's why they don't really fully lose. Okay? Okay, so go ahead. Come on, everyone. Guys, come on. So, non-metals, do you know what tend means? What does tend mean? Everyone, phones away. What does tend mean? What does it say when someone says, I tend to go to the gym late at night? What does that mean? No? Okay, but what does tend to mean? Someone says, I tend to go to the gym at night, or I tend to wake up at 5 a.m. every day. Not have to, but sure. It means what? I mostly do this. I tend to come late to class every day, 5 minutes. That means what? I mostly show up 5 minutes late. Okay? So what does tend to? Mostly. So non-metals. By the way, where are metals? Come on. Where are metals? Which side of the periodic table are metals on? Yes, metals are the what? Are the group 1, group 2, and the what? And the middle, because it's called transition metals. All the other ones there are called what? Non-metals. They're non-metals. They mostly have what? Not full. What does that mean? Instead of 8, they might have how many? You can't. Again, if you're 9, you're more than full. You can never be more than full. You're either full or what? Or what? Or less. So if you're not full with 8, what makes you almost full? 7 or 6 or? Do you see what I mean? So you're not there yet, but you're closer to being full than closer to just 1 or 2. Okay? So non-metals like oxygen, carbon, nitrogen, fluorine, bromine, all of that, tend to have almost full valence shell. So they form, what does form mean? Make. Form means make. So non-metals make covalent bonds. Come on, everyone. So fill this in. Not covalent bonds with one another. What does due? Do you remember due to? What does that mean? We covered it. What does due to? Oh, Mr. Ramadan, why did I fail this quiz? Well, you failed it due to not being in class. What does, Because of. So because of the what? What did I do with Muhammad with the gum? Sharing of what? Of what? Hey, man. Okay. Toyota Camry قدام المدرسة. Front seat. Okay. Okay. What's up? Go ahead. Okay. What's this word? Valence. What's this word? The first word on top? On what? Covalent. That's why. You are sharing the what? The valence electrons. You are sharing the valence electrons. Now here's my question to you. How many electrons does oxygen have? Let's quickly sketch it on the board. I'm gonna do it over there. I'm gonna get this. Oxygen. Can anyone remember what's the what's the number? What's the atomic number for oxygen? Like the whole thing. If you look at the periodic table right now, oxygen in the box. O, what's the number here? No, 15 is 15 is phosphorus, I think. Okay, 8. Okay, 8. So let's sketch it with 8. Here's the nucleus with 8 protons. How much on the first circle? 2 next to each other. 1, 2, 3, 4. Still need how many more? 5, 6. That makes it what? 8 in total. Okay. So, how many does this one need? To be full? No, to be full. How many? 2. Okay. Everyone, imagine if I have, look, another oxygen. Focus with this. If you understand what's going on here, you will understand today's lesson. Sahir Muhammad, join us. Same thing, right? I mean, it is oxygen, so it's identical. What? Okay, yeah, sure. My bad. Okay. So how many does this one need to be full? 2. How many does this one need to be full? 2. But I told you, they are both on which side of the periodic table? Sorry. Right side. Alipiu Haley, just look here. Mine. I'll just get you the light. They are both on the what? They can't fully gain and they can't fully lose. They don't like that. So you know what happens? Okay. What did you say? This one needs how many? 2. And this one needs how many? 2. Everyone, check this out. Just look at what I'm gonna do. Instead of putting the single ones here, I'm gonna flip the circle. I'm just gonna like spin it this way. You gotta see why. So I'm gonna put 2, 2, 1, 1. Is this still correct? Yes. Here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's good so far, right? This needs how many? 2. And this needs how many? 2. So imagine if this one just moves a little bit this way. And this one also what? Again, it's not fully here, it's just here. You with me? Okay. Those two now are close to what? To this one. So that means what? It looks like it gained how many? The two that it needs. Did it gain it or did it just get them closer? Get them closer. Okay. What's going to happen to these two? So what's going on here? Did they fully gain or did they just move some closer to each other to make them sharing? But what happened? Does this one now feel, everyone, does this one now feel like it gained 2 electrons? Does it feel like it? It did not gain. It did not fully gain. If it gained, it would be fully here and here. But does it feel like it gained? Just a little bit. How about this one? Does it feel like it gained? Exactly. So this region, we can call it the what? Sharing. What does region mean? Region. Give me another word for region. Come on. What if you say, oh, that field is a big region? Give me another word for region. Starts with A. Thank you, buddy. Area. Thank you. He's a first year engineering. Okay, so instead of, as Noah said, instead of region, I'm going to call it what? This is where they share the electrons. Again, did they fully lose or gain? Did they fully lose or gain? No, because they're both on which side of the periodic table? The right. But did they seem like they gained just a little bit? Yes. And that's what covalent means. They share. They share. By the way, do you see how they actually put the electrons here? Yes, what's up? Yeah, go ahead. Apparently here, they're sketching them as what? Come on, as what? What are these shapes? No, but what are they? Yeah, these are, but what do they look like? Points, dots, like thick blue dots, right? How about the electrons from this one? They sketch them as what? Just to tell you that these electrons come from here, and these electrons come from where? Come from there. What happened here? They are what? They get close enough. They get close enough to what? To share. And that's how these bonds happen. There is no full gain. There is no full lose. Just get close enough. And then I'm going to look like I'm what? I gained a little bit. Also, I'm going to look like I gained a little bit. So we're sharing them. But that means they're what? They're stuck being together, right? Everyone, they're stuck being together because if they get further apart, what's going to happen? Each one is going to take its own what? Each one is going to take its own what with it? Electrons. Like if I'm going to go away from you, I'm going to take my stuff with me. Only if you get very what? Very close, we can share in a sharing area. It's always where? On the sides or in the middle? Come on, if you're sharing, when we were holding the gums, were we holding it on this side, that side, or in the middle? Whenever you're sharing, you have to know that these electrons have to exist in the middle between them. Not exactly in the middle, but somewhere in the middle, okay? So go ahead, everyone, sketch this. Now, let me help you sketching it, okay? Everyone, look. Here's how we sketch it, everyone. I think you already have the circles, right? Yes, so you have a circle here. You have a circle here. Is the other circle touching? In your notes? Yeah, they are. Yes, they are. So I'm going to try my best to sketch a very similar circle. Okay. How many on the inside one? Go ahead. One here. One here. How many on this inside one as well? Come on, how many? 2. But I'm not going to sketch them as dots. I'm going to sketch them as what? Okay, everyone, do not put it as X. Tell me another shape you can use. You can use circles. You can use X's. Sure. Or maybe what? Diamond, you know, like card, like playing cards. So everyone, instead of X, I'm going to sketch it this way. Sure. But I like usually to sketch, you know, full shapes together. Okay. Hey, what's up? Oh, for the students. Awesome. Thank you. Okay. How many do I need here? No. On the outside circle. I need 6. But what did I do? I'm going to put 4 here and 2 here. So everyone, put 1 here. Sure. I mean, they put 2 here, put 2 here, and put 2 here. Are you going to do the same thing with the diamonds? Exactly the same thing. Instead of 2 here, I'm going to put them here. Instead of 2 here, I'm going to put them here. And where are the last 2 diamonds? Come on. Where are the other 2 diamonds? I only 1, 2, 3, 4, 5, 6. I still have to put 2 more. Where? No, always in the what? You see, Amar, see? You can put them above or below, who cares? There we go. What do you call this area? Like Noah said? Go ahead, I want you to write sharing area. Again, what they're trying to tell you is one of them gives its own electrons and one of them gives its own what? Electrons. But they're using X. I just want to use diamonds. That's it. It doesn't matter. By the way, could you have used dots for all of them? Yeah, like I did there. Come on, electrons, we always say they look like dots. But just to tell you that 2 dots come from here and 2 dots come from here, they give them the different shapes. That's all. Guess what, everyone? Oxygen always exists like this. When you are breathing oxygen now, oxygen gas, when you're breathing oxygen gas, it's going into your system as how many atoms together, stuck together? How many? 2. Everyone, I'll show you an example. Oxygen. There we go. Oxygen always flies in the air as how many things? Very what? You are, whenever you breathe oxygen, obviously it's much smaller than this. Whenever you breathe oxygen, you never breathe oxygen as how many atoms? Just what? No, it's always connected in how many? So when you are actually breathing oxygen, you are actually breathing oxygen atoms flying in the air like what? Like this. Do you see what I mean? Oxygen always has to exist in how many molecules, in how many atoms together? 2. Why? Because they always connect to each other this way. In a what? In a sharing situation. All right? Okay. Yes. Since they both want to gain, because they are on which side of the periodic table? Right. They are both on the right. They are gainers, but they can't both gain. They cannot both gain. So they end up what? Not able to what? They can't steal, like the old stuff we did. Or they can't steal or fully gain. Okay? Yes. Shared electrons spend time. Okay, everyone, just so you know, listen up, guys. I know that I told you they exist where? In the what? In the what? In the middle, which is the sharing area. But actually, just so you know, everyone, electrons never stop what? They never stop moving. They don't just stay here and stick. They're always what? Moving. Okay, think about it this way. Those 2 electrons are never just always here. They're always moving on which circle? The first circle. Like this one could be moving this way, and this one could be moving this way. They are always moving, but they're never just stuck in here. How about this one, and 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 this one? They're moving on which circle? The second one. But because now they're connected to this one, they could also go where? Go here. Those X's can do the same thing. You see what I mean? But they're always what? All over, and most of the time, they're where? In the what? But they're not always in the middle. So always know that electrons, everyone look, one oxygen, very close, or even touching, doesn't matter. The electrons around this is always moving around. The electrons around this always moving around. Sometimes they go to both, but the idea is what? They're all shared together, especially the ones right here, right? That's how they what? Stay stable. You might say, is it just oxygen? No. What's another gas very close to oxygen on the periodic table? What's another gas that's very close to oxygen? No, very close to oxygen. Hydrogen is on the way other side, just around the oxygen. Look at your periodic table from day 4, I think. Yeah, day 4. What's another one? There's a few. Nitrogen. Nitrogen is the same way. It always flies in how many? How many? 2 balls connected together. When you breathe oxygen right now, it's always going into your system as 2 atoms stuck together in a sharing situation. Okay? Yes, electrons is attracted to both. It can't really decide which one to go, so it stays in between. Let me just finish this one. So, everyone, what do you call something made up of 2 or more connected in a what? You do not call it ionic. You call it what? Who can read this word? Remember, we read it before. Just try to separate it into 2 words. Molecule. Actually, Cu. Moly what? Molecule. Anything with sharing is called a what? How about if it's not sharing? How about if it's ionic? You cannot call it what? Molecule. What do you call it? You call it the old names from yesterday. Ion or compound. This one we call what? Molecule. So you can never say, oh, it's an O2. It's an O2 particle. No, it's an O2 what? Oxygen gas molecule. I told you, it's a gas and it flies as 2 things stuck together. Okay? All right. Is that it for this one? I think so. Okay. Hey, what is that? H2O. What's H2O? Water. This is how water is what is connected. Everyone, pencils down. Pencils down. Let me just explain this diagram for you because I want to go and print the worksheet for you. How many does oxygen have? We already decided. No, full, all of them. 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? How many does hydrogen have? By the way, hydrogen is the very first element in the entire periodic table. What's the number for it? 1. Okay. Now, everyone, you said that oxygen has how many? Come on. Oxygen has how many? 8. 2 on the first circle. Can you ever touch these? You never touch the last circle. Sorry, the first. You touch always the what? The last circle. How many does it have on the last circle? 6. It needs how many more? So what does it do? It grabs a hydrogen, grabs another hydrogen. Now, this hydrogen has how many electrons in it? 1. So what does it do? It gets close enough. Yeah, it gets close enough from this side, and it gets close enough from this side. Now let's think. How many did oxygen have on the last shell? 6. But if you take a hydrogen from here, and you take another what? Hydrogen from here, how many electrons now do you seem to have gained? You didn't gain, but you got them closer. How many extra? 2. So oxygen now is up to how many? 8. Again, 1, 2, 3, 4, 5, 6. And now it got 1 from here and 1 from here. So oxygen now seems to have how many? No. Oxygen had 6. 1, 2, 3, 4, 5, 6. It needs how many more? So what does it do? It tells a hydrogen to come closer. It tells another what? Hydrogen to come closer. When they come close, that electron from the hydrogen is going to be shared, right? And that electron from the other hydrogen is also going to be what? So now oxygen seems to have how many now? 8. 1, 2, 3, 4, 5, 6, 7, 8. What about hydrogen, everyone? Hydrogen has how many? Again, we said that the first circle has to have how many? So hydrogen needs how many more? 1. Yes. Everyone, this is the electron of hydrogen, and this is the electron from the what? From the oxygen. Is hydrogen now happy? It has how many? No, how many around it? 2. Is this hydrogen happy? How many does it have around it? Is oxygen happy? Yes, because it has how many around it? 8. 1, 2, 3, 4, 5, 6, 7, 8. Sharing. Sharing. They are not giving fully. They are completely sharing. Question for you. What if this hydrogen moves away? What is it going to take with it? If you move them away, what is it going to take with it? It's going to take its own electron. So this X right here, will move away. How about if this hydrogen moves away? This X will move away with it. And the oxygen will go down to what? 6. 1, 2, 3, 4, 5. Sorry. 1, I'm counting these, my bad. 1, 2, 3, 4, 5, 6. That's how sharing works. You just have to know how close to bring them. And that's what both of you lock. Both of you lock. And that's it. Okay? So let's read this together. So there are 3 types of what? Who can read this word again? Covalent. Covalent. One of them is what? Single bond, which means what? One electron is being shared. There's also what? Which means what? There's also what? Which means 3 electrons are being shared. Tomorrow we will see how a single bond looks like, a double bond looks like, and a triple bond looks like. Okay? Sure.